So today we're going to be working on solving one-step equations. So for the first example, we're going to show you this. X plus 2 equals 5. So what this problem pretty much means is what number plus 2 will equal 5. Now, we all know this is an easy problem, and we might know that 3 plus 2 equals 5. But how do we show our work to solve this problem? You need to apply something called the inverse operation. So now you look at x plus 2. We see that there's an addition sign. An inverse operation means the opposite operation. So we have a plus sign. The opposite of plus, or the inverse operation of addition, is subtraction. So we need to subtract 2 to both sides. Whatever you do to one side, you do to the other. Now what happens here is this positive 2 and the minus 2, or the positive 2 and the negative 2, they cancel each other out. 2 minus 2 is 0. Now what I always do is bring down the x, I bring down the equal sign, and 5 minus 2 equals 3. Now that's how you solve a one-step equation. Let's do some more examples. Let me erase this here. Here's another example. What if we have something like this? 15 plus b equals 23. Now, we do have a plus sign right here. So now you're saying we need to subtract. Yes, but not because of that plus sign. Now look at this 15. Is that 15 positive or negative? It's positive, right? So now you need to apply the inverse operation, which is negative 15. You gotta do that to both sides. Now 15 minus 15 is 0, so I just cancel it out. I bring down the b, I bring down the equal sign, and 23 minus 15 equals 8. Now to check our work, I can plug this 8 back into b. So for example, 15 plus 8, because that was our answer, equals 23. Now 15 plus 8 is, let's see, 8 plus 5 equals 13. Carry the 1. 1 plus 1 equals 2. 23 does equal 23. So that's my answer. So now we know that b does equal 8. Let me erase this. Now let's look at another example. What about m plus 4 equal negative 12? So what number, when you add it to 4, equals negative 12? Now we need to apply again the inverse operation. You look at this 4. Is the 4 positive or negative? It's positive, and you can tell because there's a plus sign right in front of it. So you need to apply the inverse operation. That means the opposite operation of positive 4, which is negative 4. So you need to subtract 4 to both sides. Now this cancels out. I bring down m. I bring down the equal sign, and the negative minus 4 equals negative 16. Whenever you have the same signs, you add them and keep the sign. Again, if you have the same signs, for example, here we have Both of these numbers are negative. They both have a negative sign in front of it. Same signs. You add the numbers. 12 plus 4 is 16. But you keep the sign. So you keep that negative. So now my answer is negative 16. Now if I go back and check my work, I'm going to plug in negative 16 for m. You're going to copy down the problem. Okay. Now, look at this, for example. This is a negative and this is a positive. Different signs, you subtract, but keep the sign of the bigger number. Again, different signs, you subtract the numbers, but keep the sign of the larger number. So over here, I'm going to put 16 minus 4. So subtract the numbers. 16 minus 4 equals 12. Now, if I ask you what number is bigger, 16 or 4, do you rather have $16 or $4? Of course, $16. Now, what sign is next to the 16? A negative sign. So this will be negative 12. You keep the sign of the larger number. So negative 16 plus 4 equals negative 12. And does negative 12 equals negative 12? Yes. So my answer was negative 16. Let's do another one. Let me erase this. Let's see. What about if we have something like this? V minus 15 equals negative 27. Again, don't forget we need to apply the inverse operation. I need to solve for the variable v. I have a minus 15. Whenever I see a minus sign in front of that number, think about it as a negative. For example, if I write this problem down like this, v plus negative 15 equals negative 27. This here is the same as a minus sign. When you're adding a negative, it's the same thing as subtraction sign. So now, if I say pretend there is a negative in front of that 15 instead of a minus sign, what is the inverse operation of a negative slash subtraction? Of course, it's going to be addition. So now instead of subtracting the 15, I need to add 15 to both sides. Add 15 to both sides. Now this cancels out. I bring down v. I bring down the equal sign. Different signs, you subtract, but keep the sign of the larger number. So over here on this side, I'm going to do 27 minus 15. 7 minus 5 equals 2. 2 minus 1 equals 1. So I'm writing down 12 right here. So now what number is larger? 27 or 15? Do you rather have $27 or $15? I'd rather have $27. What sign is in front of that 27? A negative. So that means my answer needs to be negative. So V equals negative 12. Alright, let me erase this. Let's try another problem. Let's try this. 3 plus p equals 8. Now pause the video here so you can try it. Alright, so to solve this problem, again, you need to apply the inverse operation. Yes, we need to leave p by itself on the left-hand side of the equal sign. So what are the numbers on the left-hand side of the equal sign? Yes, the 3. Now, if you look at the 3, I need to move the 3 to the other side of the equal sign. Is the 3 positive or negative? It's positive. Now, whenever you don't see a sign in front of that 3, it's always a little invisible plus sign. So it's positive. Now, to move this positive 3 to the side of the equal sign, you need to apply the inverse operation. Now, the inverse operation of positive 3 will be negative 3. Right? Now, we're going to be subtracting 3 to both sides. This cancels out. I bring down p. I bring down the equal sign. And 8 minus 3 equals 5. Now, if I plug it back into the original problem, I have 3 plus 5 equals 8. 3 plus 5 equals 8, and 8 does equal 8. So I know p does equal 5. All right, let's move on to the next one. Here we go. So now we have n plus 16 equals 9. Ask yourself, what number do I need to move to the other side of the equal sign? The 16. You need to apply the inverse operation. When you move a number to the other side of the equal sign, you need to do the opposite operation, the inverse operation. So what is the opposite or the inverse of adding 16? Subtracting 16. Okay? Now this cancels out. I bring down n. I bring down the equal sign. 9 minus 16. Now that 9, again, you don't see a sign in front of it, so it's a positive 9. When you have different signs, you subtract the numbers, but keep the sign of the larger number. So for example, you do 16 minus 9. 6 cannot go into 9, so I gotta borrow. This turns into 0. Now, what is 16 minus 9? 7. Now, put down a 7. Now, what number is larger? Do you rather have $16 or $9? Of course, 16. Now, what sign is in front of 16? A negative. So my answer will be negative 7. Now, if I check my work, I'm going to plug in negative 7 right there. So it'll be negative 7 plus 16 equals 9. Now, if we add negative 7 to 16, remember, different signs, you subtract, but keep the sign of the larger number. 16 minus 7. Now 6 cannot go into 7. I cannot subtract 6 minus 7. So I need to borrow. This turns into 0. I put a 1 right here. Now 16 minus 7 equals 9. Now what number is larger, the 7 or the 16? Do you rather have $7 or $16? Of course, $16. Now, what sign is in front of the 16? Is it a positive or a negative? A positive. So now put a little plus sign if you want. You don't need to. Positive 9 equals 9. Again, but you don't see a sign in front of it, it's also positive. So we're good. So my answer is -7. Let me erase this. Alright, let's try something like this. $5x equals 30. Same rules apply here. You need to apply the inverse operation. You want to leave the variable x by itself. Now, whenever you see something like this, 5x, between the 5 and the x, there's an invisible multiplication sign. So it's 5 times x. What is the inverse operation of multiplication? Division. Now, to show division, I always put a bar and then the number below it. Now it looks like a fraction. A fraction, for example, if we have 1/2, look what happens if I erase the numbers, and I put 2 little dots. It's a division sign. So now, if you look at the problem, we're dividing 5 to both sides. 5 over 5 is 1. Don't forget the x. Equals 30 over 5 means 30 divided by 5. Or, how many times can 5 fit into 30? 6 times. And 1x is the same as just x. And x does equal 6. Now, if you plug it back into the original problem, where we had 5x equals 30, and then 5x is 5 times x equals 30. If I plug in 6 for x, so 5 times 6 equals 30. 5 times 6 is 30, and 30 does equal 30. So my answer is 6. Let's try another one. Let's try 2x equals 10. Again, what operation is between the 2 and the x? Multiplication. Now we need to apply the inverse operation to leave x by itself. So again, what number is next to the x? The 2. What is the inverse operation of multiplication? Division. So I need to divide both sides by 2. And 2 over 2, so 2 over 2 is 1. Don't forget the x. bring down the equal sign. 10 divided by 2, or 10 over 2. Or, how many times can 2 fit into 10? That is 5. 1x is the same as just x. So x equals 5. Now let's check our work. If I go back to the original problem, I have 2x equals 10. Or 2 times x equals 10. Now if I plug in our answer, which was 5, we have 2 times 5 equals 10. What is 2 times 5? 10. Does 10 equal 10? Yes. So x does equal 5. Let's erase this one. Now let's try, what if we had a fraction? What if we had a fraction that looks something like this? 1 over 2x equals 10. Same rule applies here about what operation is between half and the x. That is multiplication. Okay? Now, what operation do I apply to leave x by itself? Yes, it is still division. So if you divide half to both sides, you get something like this. Watch this. Half divided by half. You need to apply the keep, change, flip rule, which is keep the half, change the division to multiplication, and you flip the half to a 2 over 1. Now this, when you multiply straight across, is 2 over 2, which equals 1. And we all know that 1x is just x. Okay? Now, over here on this, on the right-hand side of the equal sign, we have 10 over half, which is 10 divided by half. If you want to put an invisible 1 underneath the 10, that is fine. You need to apply the keep, change, flip rule. So you keep the 10 over 1, you change the division to multiplication, and you flip the half to a 2 over 1. Now when you multiply fractions, you multiply straight across, and you would get 20 over 1, which is 20. So x equals 20. I'm going to show you a shortcut to this problem. Okay? Let me erase all this so I can show you the shortcut. So we had the problem like this. Okay? Here's the shortcut. We have half x equals 10. What you need to do here is, since this is a fraction, which means division, you need to multiply by the reciprocal. Sorry. You need to multiply both sides by the reciprocal. What I mean by that is a reciprocal is like this. That's the reciprocal. You flip the fraction. So multiply by this to both sides. Now what happens here is you get 2 times 1 and 1 times 2, which again is 2 over 2, which is 1 whole. So this will equal 1, don't forget the x, equals 10 times 2, which is 20, over 1. Now 1x is just x, and 20 over 1 is just 20. You see how easy that was? I prefer the shortcut. Now also, if you look at this problem here, the same one, you can read it this way. Half of what number equals 10? Again, half of what number equals 10? Half of 20 equals 10. So think about money. If you have a $20 bill, what's half of that $20 bill? $10. Let's try another problem that's very similar to this, so we can try it. Okay. 1 over 3, or 1/3. B equals 6. So now, let's apply the shortcut. All right? This here means what? A fraction, a division. To move this fraction to the other side of the equal sign, you need to multiply by the reciprocal. So multiply by 3 over 1 to both sides. Now this equals 3, and this equals 3. So 3 over 3 is 1. Don't forget the b. 6 times 3 is 18. Again, like there's an invisible 1 right here. 1 times 1 is 1. 1b is just b. b equals, what's 18 over 1? 18. Now, if I plug it back to the original problem, we had 1/3 b equals 6. Now, this means 1/3 of what number? 1/3 of what number equals 6? Yes, it is 18. 1/3 of 18 equals 6. Now, if you want to just solve it, watch this. 1 times 18 is 18. 3 times 1 is 3. Now, how many times does 3 go into 18? 6 times. Does 6 equal 6? Yes. So that way we know that B does equal 18. Now, in our next lesson, it's going to be on solving two-step equations. Now we're going to be solving two-step equations. So two-step equations will look something like this. 2x plus 1 equals 9. Now, in one-step equation, the important part of that was learning how to use the inverse operation. Guess what? Solving two-step equations, you would need to apply the same rule using the inverse operation, which is the opposite operation. For example, if you're adding, the inverse operation of adding is subtraction. The inverse operation of multiplication is division. The inverse operation of division is multiplication. And the inverse operation of subtraction is addition. So pretty much the opposite. That's what it means. Now in this problem right here, we have 2x plus 1 equals 9. Now, we need to leave x by itself. Yes, there's a 2 in front of it. But first, we need to move this number here, the 1, which is positive, to the other side of the equal sign. Now, the 1 is positive, so the inverse operation of addition is subtraction. So you need to subtract 1 to both sides. That way this cancels. You get rid of it. Now you can bring this down. You bring down the equal sign. And 9 minus 1 equals 8. See there? That's one step. We did one step right here. Now our second step, we need to get rid of this 2 next to the x. Between the 2 and the x is an invisible multiplication sign. Now to move the 2 to the other side of the equal sign, you have to do the inverse operation. The opposite or the inverse operation of multiplication is division. And I always show it by putting a bar or a line underneath like a fraction. So you need to divide by 2 to both sides. This technically cancels out. It'll be 2 over 2 is 1. Right? It'll be 1. And 1x is just x. That's why I say just get rid of it. That way you don't get confused. And now on this side we have 8 divided by 2. If you get stuck with division, maybe think about multiplication. 2 times what equals 8? 2 times what equals 8? That's correct. It is 4. So x equals 4. Now, if I write down the original problem here, we have 2x plus 1 equals 9. We can check our work. We can plug in 4 for x. This is 2 times x. So it'll be 2 times 4 plus 1 equals 9. Now, in order of operations, or PEMDAS, some of you guys know as please excuse my dear Aunt Sally, multiplication comes first. 2 times 4 is 8. And you bring down the plus and the 1. And 8 plus 1 is 9. And does 9 equal 9? Yes. So for sure, we know the answer is x equals 4. Let's try another one. Sorry, I showed you this was first step. Our second step was to divide. So that's 2-step equations. Alright, let me erase this. There you go. Learning how to use the iPad here. Looks pretty nice. Now let's do another problem. What if we had 3x plus 4 equals 16? So our first step is to move the 4 to the other side of the equal sign. You got to move this 4 because you're trying to leave 3x by itself at first. To move that 4 to the side of the equal sign, you need to apply again the inverse operation. So that means the opposite of positive 4 or adding 4 is subtracting 4, a negative 4. Now what happens here is the 4 minus 4 is 0, so it just cancels out. Next, you can bring down the 3x, you can bring down the equal sign, and 16 minus 4 is 12. Now in this problem, between the 3 and the x, there's an invisible multiplication sign. It's invisible. You got to get rid of that 3 to leave x by itself. You need to apply the inverse operation. So you need to divide both sides by 3. X equals, what's 12 divided by 3? Or 3 times what is 12? It's 4 again. Wow. 2 in a row. The answer is 4. So this is our second step right here, dividing. Our first step was subtracting 4 to both sides. So now that we got x equals 4, let's check our work. F3x plus 4 equals 16, which is 3 times x plus 4 equals 16. Remember, we got to substitute that x with the 4 from over here. So now we have 3 times 4 plus 4 equals 16. In PEMDAS, in the order of operations, multiplication goes before addition. So now we need to multiply 3 times 4, and that will give us 12. Then plus 4 equals 16. 12 plus 4 is 16. And 16 does equal 16, which concludes that x equals 4 for this problem. Feel free to pause the video when you see the original problem. Maybe you want to try it out on your own, and then you can watch the video to see if you got the answer correct. Alright, let's try another problem. Alright, here we go. Let's do 10x minus 10 equals 90. Now again, you're trying to leave x by itself. That 10x, you leave it alone at first. You need to move this minus 10 or negative 10 to the other side of the equal sign. You need to apply, guess what? The inverse operation. The opposite of minus 10, or the inverse of negative 10 or minus 10, is adding 10 to both sides. This cancels out. I bring down the 10x. I bring down the equal sign. And 90 plus 10 is 100. So this is our first step right here. We're adding 10. Okay. Our second step will come right here. We need to leave x by itself. Between the 10 and the x is an invisible multiplication sign. You got to apply, guess what? The inverse operation. The opposite or inverse operation of multiplication is division. So you need to divide both sides by 10, because again, this technically cancels out. Now you're left with x by itself. And 100 divided by 10 is 10. Now let's check our work. Let's write down the original problem. 10x minus 10 equals 90. We figured out that x is 10, so that's what we're going to be checking if it's true. Again, between the 10 and the x is the invisible multiplication sign. Now I'm going to replace that x with the 10 that we got and write everything else down. In PEMDAS, in the order of operations, in the please excuse my dear Aunt Sally, multiplication comes first. 10 times 10 is 100. Copy and paste everything else down. 100 minus 10 is 90. And 90 does equal 90. So x does equal 10. Now we're going to try a problem with a fraction. What if there's a fraction next to the variable? Let's see. All right. Let's do something like this. Half of x plus 1 equals 5. Okay, small numbers. But even if there were big numbers, you still need to solve it the same way. So first we need to leave half of x, or half times x, by itself. You need to move this positive 1 to the other side of the equal sign. You, guess what, need to apply the inverse operation. The opposite or the inverse operation of positive 1 or minus 1, of positive 1 or plus 1 is negative 1 or minus 1. So you need to subtract 1 of both sides. Now this cancels out. I bring down the half of x, bring down the equal sign. 5 minus 1 equals 4. Now that was step number 1, the first step. Now the second step would be to guess what? When you have a fraction, just like we did when we were solving one-step equations, whenever you have a fraction next to a variable and you need to move that fraction to the other side of the equal sign, you have to multiply both sides by the reciprocal of that fraction. So you got to flip the fraction over. Again, when you multiply fractions, you multiply straight across. You're going to get 2 over 2, which equals 1. And 1x is just x. So technically, the reason why we do this is to cancel this out. X equals, now, again, if you want to apply that invisible 1 underneath as a denominator, you can. 4 times 2 is 8. And 1 times 1 is 1. So x equals 8. That's what we got as an answer. But are we right? Let's check our work. So we have half of x plus 1 equals 5. Again, we found out that we solved that x is 8. Between that half and the x is a multiplication sign. Now, I'm going to write down this problem again, but substituting the x for an 8 and copy and paste the rest. In the order of operations, in PEMDAS, and please excuse my dear Aunt Sally, multiplication comes first. So I need to multiply 1 times 8 and 2 times 1. And you're going to end up with 8 over 2. Then I'm going to copy everything else down. Plus 1 equals 5. Again, whenever you have a fraction, that's division. In order of operations, division comes first. 8 divided by 2 is 4. Copy and paste the rest. 4 plus 1 is 5, and 5 does equal 5, which concludes that x does equal 8. Good job. If you guys got this correct, if you guys tried it on your own, and you guys got it correct, give yourself a pat on the back. Feels good knowing how to do these problems. Let's try another problem. What if I write the same problem down, but instead of adding 1, we are subtracting 1? Do we still get the same answer? Alright, let's see. We had half times x plus 1, but instead of plus 1, minus 1 equals 5. Again, you need to move this 1 to the other side of the equal sign, and we can count it as a negative 1. What is the opposite or the inverse operation of negative 1 or minus 1? Is adding 1 or positive 1. That way, this cancels out. And now I bring down half of x. I bring down the equal sign. And 5 plus 1 is 6. Okay. Next. Oh, hold on. Let me write this down. That was our first step. Our second step is that we're going to move that half to the other side of the equal sign because you're trying to leave x by itself. Whenever you move a fraction that is next to a variable, just like in this problem, you need to multiply both sides by the reciprocal. So you need to multiply by 2 over 1. That means I am flipping the fraction. This will technically cancel out. It'll turn into a 1x, and 1x is just x. So that's why I just cancel it out. Now, under the 6, if you want, you can apply the denominator 1 because it's invisible. You can multiply. You have to multiply straight across. 6 times 2 is 12. And 1 times 1 is 1. And 12 over 1 is just 12. Let's check our answer. Because in the last problem we got 8. In this problem we got 12. Let's see if we got it correct. So I'm going to write down the original problem here. Now we know that x is 12. So now I'm going to plug it in here. Minus 1 equals 5. Now you can apply again that denominator 1 underneath. You have to multiply first because in order of operations in PEMDAS, multiplication goes first. 1 times 12 is 12. 2 times 1 is 2. I'm going to copy down everything else. Now, in PEMDAS, in order of operations, you need to do division before subtraction. So again, division comes before subtraction. 12 divided by 2 is 6. And then I copy and paste everything else down. 6 minus 1 is 5. And 5 does equal 5. So I conclude, or we can conclude, that x does equal 12. Let's try a similar problem, but writing it a little bit different. What if the problem looks like this. Ten equals 5 plus 1 over 3x. Our goal is still the same. We need to leave x by itself. You first need to move this 5 to the other sign of the equal sign. To the other side of the equal sign. Now you look in front of that number 5. If you don't see a sign, that means if you don't see an operation like a plus or a minus sign there, that means it's positive. So it's a positive 5. To move this positive 5 to the side of the equal sign, you need to subtract. You got to do the inverse operation. So you need to subtract both sides by 5. This cancels out. Now I left 1/3 x alone on the right side of the equal sign. That's what we want. And 10 minus 5 is 5. Now again, our goal is to leave x by itself, right? So this was our first step. Our second step is going to happen right over here. Again, we have a fraction next to a variable. When you need to move the fraction to the side of the equal sign to leave the variable alone, you need to multiply by the reciprocal. That means you're going to multiply both sides by 3 over 1. Multiply by 3 over 1. Now this will cancel out. Now you're left with x. I'm going to bring down the equal sign. 5 times 3 is 15. And 1 times the invisible 1 as the denominator is 1. And 15 over 1 is just 15. Now let's check if our answer is correct. I'm going to write down the original problem here. Now we solved it and we got 15 for x. Between the 1/3 and the x is the invisible multiplication sign. Now I'm going to write it like this. Copy and paste everything else down. But now I'm going to substitute that x for the 15. Now in the order of operations, in PEMDAS, multiplication comes before division, addition, and subtraction. So we're going to multiply first. Okay. We have 1 times 15, which is 15. So 1 times 15 is 15, and 3 times 1 is 3. Now I'm going to copy and paste everything else down. Now, this fraction here is actually division. We're going to divide. Why do we divide first? That is because in PEMDAS, in the order of operation, division comes before adding. 15 divided by 3 is 5. Now I'm going to copy and paste everything else down. 5 plus 5 is 10, and 10 does equal 10. So we can conclude that x equals 15. Now we're going to be working on solving equations with parentheses. I'm going to show you 2 ways solving the same problem. So I'm going to do this, put this in half. So this is what I mean. Parentheses, pretty much using the distributive property. So something like x plus 4 equals 10. I'm going to write the same problem on the right hand side. Okay. Now, normally people would solve this problem, or students would solve this problem using the distributive property by multiplying the number that's outside the parentheses to the numbers / variables that are inside the parentheses. So the first one we're going to multiply is 2 times x, which equals 2x. And then 2 times 4, which equals 8, and that's positive. And I'm going to copy and paste the equal sign and the 10. Now, just like we did when solving two-step equations, we first have to move that positive 8 to the other side of the equal sign. I would need to use an inverse operation. What is the inverse operation of positive 8 or adding 8? Subtracting 8 or negative 8. Now 8 minus 8 is 0. Now I bring down my 2x. I bring down the equal sign. And 10 minus 8 equals 2. Now I need to get rid of this 2. I got to move this 2 to the side of the equal sign to leave x by itself. Between the 2 and the x is an invisible multiplication sign. You need to use an inverse operation to move that 2 to the other side of the equal sign. What is the inverse operation of multiplication? Or what is the opposite of multiplication? Division. So you divide both sides by 2. Now what happens here, on the left-hand side, 2 over 2 is 1. X equals 1. But 1x is just x, so I just copy and paste the right-hand side. So x equals 1. Now that's how we solve the problem using distributive property. That means multiplying the number outside the parentheses to the number inside the parentheses. That means we're distributing that number. Now on the right-hand side, I am not going to apply a distributive property. This is what I'm going to do first. Between the 2 and the parentheses is an invisible multiplication sign. I'm going to get rid of this 2 by moving it to the other side of the equal sign. To do that, I am going to divide. I got to do the inverse operation. So I'm dividing both sides by 2. What happens here is it technically cancels out. It turns into 1. But 1 times any number is just that number itself. So it technically cancels out. I'm going to bring down what's inside the parentheses, which is x plus 4. You do not need to write the parentheses anymore, because we're not going to be distributing anything. Equals, what is 10 divided by 2? Or 2 times what is 10? That is 5. Now, just like we did solving one-step equations, you need to move this 4 to the other side of the equal sign to leave x by itself. You need to apply the inverse operation. What is the opposite / inverse operation of adding 4 or positive 4, negative 4, or minus 4? Now 4 minus 4 is 0. I bring down the x. I bring down the equal sign. And 5 minus 4 equals 1. And if you look on the left-hand side, we got the same answer. X equals 1. But how do you check your work? Simple. You can plug it back in to the original problem. You can do it right over here, the bottom right. So we have 2 parentheses x plus 4 equals 10. Now I'm going to substitute that x for that 1. Now remember, in PEMDAS, order of operations, the P in PEMDAS stands for parentheses. That comes first. We got to look inside the parentheses. We have a 1 plus 4. So you have to add first, and that'll be 5. And then I have a 2 equals 10. Now I have 2 times 5, and that is 10. Does 10 equal 10? Yes. So we know that x does equal 1. Let's try a different problem. I'm going to show you guys doing it both ways again. But again, like I said before, feel free to just pause the video and try solving it, and then unpause the video to check your work. Alright, let's see. Here's another one. 3 parentheses x plus 3 close the parentheses equals 12. Now I'm going to copy this on the other side as well. 3 parentheses x plus 3 close the parentheses equals 12. Like I said, feel free to pause the video right now, solve it, try solving it both ways. If you only know one way, that's fine. Try it out. Practice makes perfect. Alright, so I'm going to start. On the left-hand side, I'm going to apply the distributive property. That means I'm going to distribute / multiply the 3 that's outside the parentheses to the number / variable inside the parentheses. So 3 times x is 3x. 3 times positive 3 is positive 9. And copy and paste the equal sign and the 12. Now I'm going to apply the inverse operation just like we've done before with the solving one-step, two-step equations. I got to move this 9 to the other side of the equal sign. This is a positive 9 or adding 9. You got to do the opposite or inverse operation of that, which is minus 9 or negative 9. 9 minus 9 is 0. I bring down the 3x. I bring down the equal sign. 12 minus 9 is 3. Now, between the 3 and the x and the multiplication sign, I got to move this 3 to the side of the equal sign. You get to apply the inverse operation, which is of multiplication, which is division. So I'm going to divide both sides by 3. And this technically cancels out. X equals, what is 3 over 3? That is 1 whole. Again, we got 1 as an answer. On the right-hand side, I am not going to apply the distributive property. I'm going to first move the 3 that's outside the parentheses to the other side of the equal sign. Now, between the 3 and the parentheses is an invisible multiplication sign. You need to apply the inverse operation of multiplication, which is division. So I need to divide both sides by 3. Now this, again, technically cancels out. Now bring down what's inside the parentheses. Again, you do not need the parentheses anymore. 12 over 3 equals 4. Now this is one-step equation. To leave x by itself, I got to move this 3, the positive 3, to the side of the equal sign. You need to apply the inverse operation. What is the opposite of positive 3? Negative 3. Now this pretty much cancels out. X equals, what is 4 minus 3? Yes, of course, it's 1. Look at this here. X equals 1 and x equals 1. Check my work. All right, let's check the work. I'm going to write down the original problem here. If I substitute that x for the 1, I get 3 parentheses 1 plus 3 equals 12. Now in PEMDAS, we do parentheses first. So you need to add 1 plus 3, which equals 4. Now, whenever you see a number next to a parentheses when there's no operation between them, that is multiplication, so it's invisible, just like over here. It's invisible. 3 times 4 is 12. And does 12 equal 12? Yes. So we know that x does equal 1. Let me erase this. What if there was a fraction outside of the parentheses? Let's try it out. I think I got it all. Yep. Okay, what if it was 1 over 2, parentheses, x plus, let's just say 6 equals, let's use 14. I'm going to do copy and paste the same problem on the right hand side. Now I'm going to, on the left hand side, I'm going to apply the distributive property, which again I'm going to multiply the number outside the parentheses to the number inside the parentheses / variable. Now half times x is simply half x. Half times 6, that pretty much means, what is half of 6? 3. Now it's a positive 6, so put a plus sign right there. Remember, when you multiply fractions, you just, for example, in this case, half times 6, it just means what is half of 6, which is 3. And copy and paste the equal sign and the 14. Now you're trying to leave the half of x alone. Don't do anything to that yet. You have to move that positive 3 to the side of the equal sign. What is the inverse operation of adding 3? What is the opposite of positive 3 or adding 3? Subtracting 3 or negative 3. This technically cancels out. I bring down the half of x, equal sign, and 14 minus 3 equals 11. Whenever you have a fraction next to a variable and you have to move it to the other side of the equal sign, you need to multiply by the reciprocal. That means you're going to flip the fraction. You're going to multiply by 2 over 1. Now this technically cancels out. I bring down the x. I bring down the equal sign. 11 times 2 is 22. Again, there's an invisible 1 here. 1 times 1 is 1. And 22 over 1 is just 22. It's a big number as an answer, right? Well, let's check our work over here on the right hand side. Let's see if we get the same answer. Let's see if we get the same answer, but by not distributing, by doing what I did before, by moving that half or that number outside the parentheses to the side of the equal sign first. So to do that, again, there's an invisible multiplication sign right here. Just like we did over here, I am going to multiply both sides by the reciprocal. That means multiply by 2 over 1. Multiply by 2 over 1. Now what happens here, this cancels out. I bring down x plus 6, the equal sign. 14 times 2. That means if I double the 14, I get 28. And then there's an invisible 1 here. 1 times 1 is 1. Now that simply just means 28 over 1 is just 28. Now just like solving one-step equations, you need to move that 6 to the other side of the equal sign to leave x by itself. What is the inverse operation of adding 6? Subtracting 6. Subtracting 6. Now the 6 minus 6 cancels out. I bring down the x, I bring down the equal sign, and 28 minus 6 equals 22. Look at it here. We get the same answer. Let's check our work. I'm going to write down the original problem here. Half parentheses x plus 6 equals 14. Now I'm going to substitute the x for the 22. Now in order of operations in PEMDAS, parentheses comes first. So you need to add 22 plus 6, which equals 28. Now what's half of 28, or half times 28? Which again simply means what's half of 28? That is 14. Does 14 equal 14? Yes, it does. So x does equal 22. Let's see, let's try one more with a fraction. Feel free to pause the video after I write down the problem so you can try it out. All right, here we go. Let's see, our new problem is going to be, let's just try a third. X plus 12 equals 24. Same over here. Oh, not a half. A third. X plus 12 equals 24. Feel free to pause the video and try it out. Try solving it both ways. Sometimes, you may feel that the distributive property is easier than solving it the other way, or then vice versa. Either way, you get the same answer. Practice makes perfect. So on the left-hand side, I'm going to apply the distributive property. A third times x equals 1/3 x. 1/3 times 12 equals 4. What's a third of 12? Pretty much 12 divided by 3. That equals 4. Copy and paste everything else. That's a 4, by the way. Now I need to apply the inverse operation because I need to move this positive 4 to the other side of the equal sign. So I'm going to subtract 4 to both sides. 4 minus 4 is 0. I'm going to bring down 1/3 x, the equal sign, and 24 minus 4 is 20. Now we have a third x equals 20. Whenever you have a fraction next to a variable and you need to move that fraction to the other side of the equal sign, you need to multiply by the reciprocal. Multiply by 3/1, which is simply just 3, okay? So you're going to multiply by 3. This cancels out. I bring down x, I bring down the equal sign, and 20 times 3 is 60. Now let's try on the right-hand side. I am not going to apply this to your property. I'm going to multiply both sides by the reciprocal, 3/1. That way I get rid of this. Now I'm left with x plus 12 equals, now 3/1 is just 3. So what is 24 times 3? Well, 3 times 4 is 12. Carry the 1. 3 times 2 is 6 plus 1, 7. Now, just like solving one-step equations, you need to leave x by itself. So you got to move this positive 12 to the side of the equal sign, and you need to apply the inverse operation. What is the opposite of positive 12 or adding 12? Subtracting 12 or negative 12. So I'm going to put minus 12 at the bottom there. 12 minus 12 is 0. I bring down the x. I bring down the equal sign. 2 minus 2 is 0. 7 minus 1 is 6. So my answer is 60. Look at here. We get 60 on both sides. Let's check our work. I'm going to write down the original problem here. Now I'm going to substitute that x for the 60. Now, in order of operations / PEMDAS, parentheses comes first. So I'm going to add 60 plus 12, which is 72. Copy and paste everything else down. Now multiplication is next. So 1/3 of 72, or 72 divided by 3, is 24. Does 24 equal 24? Yes. So now we know that x does equal 60. Alright, so now we're going to be solving equations with brackets. Now, brackets doesn't come up very often in math, but you will see them at some point. So if you're stuck with them, stick with us, and we'll show you how to solve problems. Here we go. Let's start with something simple like this. Say we have a bracket, x plus 3 minus 1, close that bracket, plus, let's just say, 2 equals 8. Now, I know in order of operations, we have, or in PEMDAS, we don't have the letter B in there. You know where that B would be at? So let's say we have PEMDAS. I'm going to write it over here on the right-hand side. Somewhere over here. So we have PEMDAS. The letter B for brackets will be up here. That is the first thing you would need to solve for. Everything that's inside the brackets will go first. For example, if you look at the problem, we have in brackets x plus 3 minus 1. Now again, you got to combine the like terms. The like terms there are that positive 3 and that negative 1, or that 3 minus 1. Same thing. Now you have to solve for that first. That would equal 2. Bring down the x, and I'll put down the brackets. Now, could we combine the x and the 2, the x plus 2? Could we add those two together? No, you can't. So we're done with the brackets. So let's get rid of them. So now we have x plus 2 equals 8. Now we could add 2 plus 2 because those are like terms. And that'll be 4. And I'm going to copy and paste everything else down. Now, to leave x by itself, I would need to subtract 4 to both sides. The 4 and the 4 cancel out. I bring down the x. I bring down the equal sign. And 8 minus 4 equals 4. So that's our answer, but we don't know if we're correct. Let's check our work. I'm going to write down the original problem. So pretty much copy and paste it. I'm going to substitute that x for that 4. But I'm still going to leave the brackets there. Plus 2 equals 8. Okay. Now again, solve everything that's inside the brackets first in PEMDAS. Now if you look at inside the brackets, you can use PEMDAS in there. Now addition and subtraction, whichever one comes first from left to right, you do first. So we're going to add 4 plus 3, which is 7. And I'm going to copy down everything else. Copy and paste. Now 7 minus 1. Again, we're not done with the brackets. 7 minus 1 is 6. Now we're done with the brackets. There's nothing else to do, so I'm not going to draw the brackets again. Copy and paste everything else. 6 plus 2 equals 8. Does 8 equal 8? Yes. So we know that x does equal 4. Let me erase all this down. Let me erase all of this, and then let's try another one. Let's see here. There you go. Sometimes you will see a long bracket. Okay, let me show you what I mean by that. So something like this. So we have x plus 7 minus parentheses 3 plus 2 brackets. Let's see. Minus 1 equals whatever, 10. Now, if you look inside the brackets, you need to apply PEMDAS, order of operations. Parentheses goes first, right? Inside the brackets, because we know brackets will go first, priority. You look inside the brackets. Now we got to use PEMDAS. Parentheses goes first. 3 plus 2 is 5. Now we're done with the parentheses, so I don't need to draw that again. But I'm still going to draw or copy and paste everything else. Inside the brackets, still need to apply PEMDAS. Or just combine like terms, right? 7 minus 5 is 2. Copy and paste everything else. Now inside the brackets, I could not, so I repeat myself, I could not combine the x and the 2. I just can't do that. They're not like terms. So you copy and paste everything without the brackets. Now on the left hand side of the equal sign, I can combine the 2 and the 1. That's 2 minus 1, which is 1. Copy and paste everything else. Now I need to subtract both sides by 1, and x equals 9. Now let's check our work. I'm going to do it over here. I'm going to split it up like this. Put brackets. X plus 7 minus 3 plus 2 brackets minus 1 equals 10. Now I'm going to replace that x for the 9 that we got. So use brackets. Okay. Now we need to first, again, inside the brackets, solve for parentheses. And that'll be 5. Still inside the brackets. PEMDAS. We have an addition and subtraction. Whichever one comes first from left to right, you do first. So it'll be 9 plus 7, which is 16. Still have brackets. 16 minus 5 is 11. I don't need the brackets anymore. I'm done with it. 11 minus 1 is 10. Does 10 equal 10? Yes, they do. So now we know that our answer equals 9. Now we're going to solve equations with exponents. So a problem with exponents that revolves solving equations will look something like this here. X squared plus 10 equals 26. Just like solving one-step equations or two-step equations, you want to leave x by itself. Now, x is on the left-hand side of the equal sign. What else is on the left-hand side of the equal sign? The plus sign and that 10. I need to move this 10 to the other side of the equal sign. To do that, again, we need to use the inverse operation. Now, what is the inverse operation? It means the opposite operation. So if you're adding, the opposite of adding, subtracting. If you're multiplying, the opposite of that is dividing, and vice versa. So right here we're adding 10. The inverse operation of adding 10 is subtracting 10. You need to subtract 10 to both sides. Now what that does, it gets rid of this 10. So that's why we're moving it to the side. Now we're left with x squared on the left-hand side of the equal sign, and 26 minus 10 equals 16. Now you're wondering, what about this exponent here? Yeah, you're right. We don't want to know what x squared equals. We want to know what x equals. To get rid of a squared or an exponent, you need to do this. On both sides, use a squared root. Just like this. Now what happens here is this gets rid of the squared root. The squared root gets rid of the exponent. Now, I bring down the x, I bring down the equal sign, and the squared root of 16 is 4. Now let's check our work, just to prove it to you guys. We have x squared plus 10 equals 26. Now I'm going to substitute the x for a 4 because that's what we got over here. So I'll put 4 squared plus 10 equals 26. In PEMDAS, in the order of operations, exponents comes before adding. So I'm going to find what 4 squared equals. This means 4 times 4, which equals 16. And I'm going to copy and paste everything else. Now 16 plus 10 equals 26. And does 26 equal 26? Yes. So x does equal 4. Let me erase this. Let's try another problem. Feel free to pause the video and try it on your own. Follow the same steps. Okay. X squared plus 9 equals 34. Okay, man. So again, pause the video, try it on your own, and then play the video to make sure you got it right. If you didn't get it right, just fix your mistake. We learn from mistakes. We're humans. So our first step here is to subtract both sides by 9. That way the 9s cancel out. I bring down the x squared. I bring down the equal sign. 34 minus 9 equals 25. To get rid of the square, the power of 2, to get rid of the squared, you need to use the squared root. Now this squared root will cancel out the square root of the power of 2. Now I'm left with x by itself. The square root of 25 is 5, because 5 times 5 equals 25. Now let's check our work over here. I'm going to copy down the original problem. Now I'm going to substitute the x for a 5. And copy and paste everything else. Now again, in order of operations, in PEMDAS, exponents comes before addition. So we need to figure out what 5 to the power of 2 is. 5 squared means 5 times 5. I'm going to copy and paste everything else. 5 times 5 equals 25. And 25 plus 9 equals 34. And does 34 equal 34? Yes. So now we know that x does equal 5. Now let's try another one, a little bit different. This time, instead of to the power of 2, what if we have to the power of 3? Let's try it out. Let's see. Let me erase this here. Almost there. Let me know if you guys are actually enjoying this iPad. The writing, I think it's okay. But I don't know on your end. I don't know if it looks good or not. Let me know in the comments down below. Okay, let's see. So there's another problem. It's x to the power of 3. Let's try plus 3 equals 12. Okay. Now, just like solving the previous problem, we need to move that positive 3 to the other side of the equal sign. So we got to use the inverse operation. Instead of adding 3, I need to subtract 3 to both sides. Now, what that does on the left-hand side, the 3's cancel out. Now I'm left with x cubed, or to the power of 3, x cubed equals 12 minus 3 equals 9. Now to get rid of that cubed, or to the power of 3, you need to use a cubed root, which looks like this. And you'll see a little 3 right here. Whatever you do to one side, remember you gotta do it to the other side. Now I'm gonna do a little note section over here. Okay. Now, cube root means what number can you multiply 3 times by itself to get the number inside the cube root. So again, a cube root means what number can you multiply by itself 3 times to get that number inside that root. Okay. So now, let's go back to the problem on the left-hand side. The cube root gets rid of the cubed. Now I have x by itself. Now if you look at the right-hand side, what number can I multiply by itself 3 times to get 9? That's just the tricky one. So now some of you guys will say 3, because 3 times 3 equals 9. But no, it's not going to be 3. What would it be? You think it's 2? What is 2 times 2 times 2? Well, 2 times 2 is 4, and 4 times 2 is 8. Again, 2 times 2 times 2. That's 4 times 2 equals 8. Now what about 3 times 3 times 3? Well, 3 times 3 is 9. But what about 9 times 3? That's 27. So it's somewhere between 2 and 3. Somewhere in here. Now the answer, if we round it, will be 2.08. That's if you round it. Now, that will be your answer. So it's going to be a little bit difficult to check your work on this problem, because if you plug 2.08 back to the original problem, you're going to be very, 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 very close to 12. You're going to get like 11.9 something, something, something. How about we try something that we can actually get a whole number? That way I can show you guys what I mean. Let's see. Okay. What about something like this? Oh, there's my pencil. There it is. What if it was cubed root? Let's see. Minus 5 equals 120. It's a better one. Now again, I need to move that 5 to the other side of the equal sign. What is the inverse operation? Adding 5. Now the 5's cancel out on the left hand side. I bring down the x to the third power. I bring down the equal sign. 120 plus 5 equals 125. Again, to get rid of that cubed, to get rid of this cubed, you need to use a cubed root. Now the cubed root gets rid of the cubed. I bring down x, I bring down the equal sign. Now what number can I multiply 3 times by itself to get 125? It's going to be 5. I'll show you real quick. 5 times 5 times 5. Well, 5 times 5 is 25. 25 times 5. Well, think about money. Let's pretend 25 was quarters. Just think real quick. Quarters. If you have 5 quarters, that is $1.25. Now here we don't have any quarters, so there's no decimal. So my answer is 125. So we know that x equals 5. But let's check our work. I'm going to write down the original problem over here. Now I'm going to substitute the x for a 5. 5 to the third power minus 5 equals 120. Now we already saw this over here. 5 to the third power, that equals 125. Now I'm going to copy and paste everything else. 125 minus 5 is 120. Does 120 equal 120? Yes. So we have our answer. X does equal 5. Oh. Let's see. Let's go back and review just a bit of what we learned so far. Let me write this down. Up here. I'm going to put review, solving equations. All right. Let's do one-step equations. So I'm going to write down 3 different problems. How about that? Let me write down 3 different problems, and then we're going to solve them. That's x plus 11 equals 20. That's 1. X 2x, no, oops. What was I going to do? Yeah, sorry. 2x equals 40. Let's do another one. Negative 4 plus x equals 10. Now let's start with the first one. Our first step and only step is to subtract both sides by 11. Now the 11's cancel out. I bring down the x, I bring down the equal sign, and 20 minus 11 is 9. Now in the middle, 2x means 2 times x. So I need to divide both sides by 2. X equals 40 divided by 2. That means, what's half of 40? 20. Now on the right hand side, I gotta move this negative 4 to the other side of the equal sign. What is the opposite or inverse of negative 4? We're going to be adding 4 to both sides. Now, a negative 4 plus a 4, that cancels out, 0. Now I bring down the x. I bring down the equal sign. And 10 plus 4 equals 14. Easy, right? Do you guys remember what to do when there's a fraction? Let me erase the first one. What if there was a fraction here? What if it was 2/3? Right? 2/3 x equals 10. Do you remember what you have to do? You need to multiply both sides by the reciprocal. That means I'm flipping the fraction over. So like this. That way this turns into nothing. It's 1. 1x is just x. I bring down the equal sign. Now when you're multiplying fractions, you just multiply straight across. So there's an invisible 1 right here. I multiply straight across. 10 times 3 is 30. 1 times 2 is 2. I'm not done yet. I could simplify this. Now 30 over 2 means what's half of 30? And that's 15. And there you go. The next one we're going to do is two-step equations. Let's see, almost there, almost there. So two-step equations look something like this. 2x plus 4 equals 24. Another one. 1/4 x plus 2 equals 8. Now another one. What if we had a negative? Negative 5x plus, let's say, 20 equals 40. All right, let's start with the left-hand side. We have 2x plus 4 equals 24. Now my first step here is to subtract both sides by 4. This equals 0. 2x equals 20. Then my second step is to divide both sides by 2. The 2 technically cancels out. X equals, what's 20 over 2, or 20 divided by 2? 10. Now the middle one. I first need to subtract 2 from both sides. 2 minus 2 is 0. I bring down the 1/4 x. Bring down the equal sign. 8 minus 2 is 6. Now again, for my second step, I need to get rid of that fraction. I need to move it to the other side. Whenever you move a fraction to the other side, you need to multiply by the reciprocal. So multiply by the reciprocal. That means I'm flipping the fraction over. So technically this cancels out. X equals 24 over 1, which equals 24. Now on the right-hand side, it's still, even though you see a negative, it's still going to be a two-step equation. So I need to subtract 20 from both sides. I bring down the negative 5x. I bring down the equal sign. 40 minus 20 equals 20. Now I need to divide both sides by negative 5. Not just by 5, but by negative 5 to get rid of this. Now a positive, so we have a positive right here, divided by a negative is negative. So now you just simply divide normally. 20 divided by 5, which equals 4. So my answer, let me write it a little bit better, is negative 4. So those are two-step equations. What about when there was parentheses? What about parentheses? Let's see here. Let me erase all of this. All right. So there was let's see, something like this right here. 2 parentheses x plus 8 equals 32. What if let me see. Let me write this one down. 3 parentheses x minus 12 equals 36. Now, what about 4 parentheses x plus, let's see, just do 1 equals, let's see, 16. Sure. Now for this part, because I'm going to do this twice, but 2 different ways. The first way, I'm going to use distributive property. And the second way, I am going to get rid of the number outside the parentheses first and then solve for the variable. So for now, I'm going to use distributive property. That means I'm going to multiply the number outside the parentheses to the numbers inside the parentheses or variable. 2 times x equals 2x. 2 times 8 equals 16. Copy and paste everything else. Now I'm going to subtract 16 from both sides. Now I have 2x equals 16. Divide by 2 now. And x equals 8. Now on this side again, we gotta multiply it. I have 3x. 3 times x is 3x. 3 times negative 12 equals negative 36. And copy and paste everything else. Now I need to add this 36 to the side of the equal sign. 3x equals 72. Now I gotta divide 3 to both sides. Now x equals 24. Now on the right hand side, on the far right, I'm going to multiply 4 times x and 4 times 1. 4 times x is 4x. 4 times positive 1 is positive 4. Copy and paste everything else. Now I'm going to subtract 4 to both sides. That is 0. Bring down the 4x. Bring down the equal sign. 16 minus 4 equals 12. Now I need to divide 4 to both sides. X equals 3. So I'm going to write down the answers that we got from these problems all the way at the bottom. So x equals 8, x equals 24, and x equals 3. Now we're going to solve the same problems, but by first getting rid of the number outside of the parentheses. So let me erase all of this then. You guys may choose, like when you're in class, doing homework, as long as you show your work, you'll get full credit. Let me erase these arrows. Okay. Almost there. Alright, perfect. Alright, so now I'm going to get rid of the number outside the parentheses first. I'm going to divide both sides by 2 over here. What happens here gets rid of that. Now I'm just left with x plus 8 equals. Now what's 32 divided by 2? Now what's half of 32? That will be 16. Now my next step is to subtract 8 of both sides. This cancels out. X equals 8. Look at the bottom. Same answer. Let's look at the middle, the center. I'm going to first divide 3 to both sides. The 3's canceled out. Well, technically turns into a 1, but it's nothing. It's invisible. I'm going to write down x minus 12. Oops. There you go. X minus 12 equals. Now 36 divided by 3 is 12. Now I'm going to add 12 to both sides. X equals 24. Now look at the bottom. Same answer. Now the right hand side. I'm going to divide by 4 to both sides. The 4 technically cancels out. I'm going to bring down x plus 1, the equal sign, and 16 divided by 4 equals 4. Now I'm going to subtract the 1 to both sides. And x equals 3. Now look at the bottom. Same answer. So again, you choose what method works best for you. There are times where it's going to be a little bit hard to use this second method. So I'm going to show you an example why. We'll erase the one in the middle. Okay. I'm going to show you why sometimes you probably would not like this method. Let's say we have something like this. 3 parentheses x plus 1 equals 8. Now look what happens when we use this same method. The method where we get rid of the number next to the parentheses first. If I divide 3 to both sides, yes, the 3's pretty much cancel out. I can write x plus 1. But 8 cannot divide into 3 equally. Like, you will not get a whole number. You're going to get a decimal. It'll be 2 point something. 2 point blah, 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 blah. So this, at this time, it would not be best to use this method. It'll be best if you use distributive property. You will get 3x plus 3 equals 8. Subtract 3 to both sides. 3x equals 5. Then you divide it by 3. And you'll get x equals 1 2/3, which equals 1.66666, and so on and so forth. That'll be a lot easier. So there's going to be times when you are going to be able to use it. You just got to check the number outside the parentheses and the number after the equal sign to see if it would divide equally and get a whole number evenly. You get a whole number. All right, let me erase all this. Keep erasing those letters up there. There you go. Now let's do the ones with exponents. Just a quick practice. This one doesn't have to take too long. More for review. Take a sip of water. Stay hydrated. Let's see. X to the second power plus, let's say, 10 equals 91. Let's try another one. X to the second power minus, let's say, 12 equals, let's see, 15. X to the third power oh, sorry, that's the one I meant for the third power. X minus 12, X 15. Okay. Now this one was, I was going to do this one right here. X minus 19 equals 30. There you go. Alright, if you want to pause the video right here and try it out yourself, you may do so. I recommend it. Alright, I'm going to start with the left-hand side. I'm going to first subtract 10 to both sides. The 10s cancel out. I bring down the x squared. Bring down the equal sign. 91 minus 10 is 81. Now to get rid of a squared of an exponent to the second power, I am going to use a squared root. Now, I haven't shown you guys this before, but look, the square root, there's an invisible 2 right here. That's what squared means. It's 2 squared roots. So what happens there is that these cancel out. A squared root and an exponent to the second power, they will cancel out. Now bring down the x, bring down the equal sign. The square root of 81 is 9, because 9 times 9 equals 81. Now in the center, I'm going to add 19 to both sides. The negative 19 and the positive 19, that will cancel out. I'm going to bring down the x squared. Bring down the equal sign. 30 plus 19 is 49. Again, guess what? We got to use the squared root. The squared root will cancel out the squared. Bring down the x, bring down the equal sign. And the square root of 49 is 7, because 7 times 7 equals 49. Now, on the right-hand side, it's a little bit different. I'm going to first add both sides by 12. The 12s will cancel each other out because I have a negative and a positive. Now bring down the x cubed, the equal sign, and 15 plus 12 is 27. Now again, I'm not going to use the squared root. That's not what I'm going to do. I'm going to use the cubed root. The cubed root. Now, the cubed root and the cube will cancel each other out. I'm going to bring down the x, bring down the equal sign, and cube root of 27 is 3. Now, why, you may ask? 3 times 3 times 3. So we have 3 times 3 is 9, and 9 times 3, 27. So these are your answers here. Thank you for watching. Click the like button and subscribe for more. Thank you.